This video is on applications of quadratic equations. So one of the first applications we're going to talk about here is the Pythagorean Theorem. And use the Pythagorean Theorem specifically with right triangles. Sometimes people get this confused with all triangles. You're going to use it with right triangles only. And it's used to find the length of an unknown side. So if I have a right triangle here, A, B, C, remember A and B are called the legs of the triangle. C, the side opposite the right angle, has a special name we call the hypotenuse. And the formula for the Pythagorean theorem is a squared plus b squared is equal to the hypotenuse squared, so c squared. A and b are interchangeable in this formula. You know, the leg and the leg doesn't matter because you're adding them. So you got a squared plus b squared equals c squared, always has to be by itself on the other side of the formula. Now, you've seen this before, in all likelihood being in this course, but let's just make sure that you know exactly how to use it. So it says for each right triangle below, find the length of the unknown side. So for the first one here, A, they told us this side is 6, this side is 8, and we don't know what this side here is. I'll call it X. You can use any variable you want, really. You might use C, because that's how you see it above. Which side's the hypotenuse here? Well, the hypotenuse is the side opposite the right angle, so that is our side that we called X. So to solve this, I'm going to use, 8 squared plus 6 squared equals X squared. Remember, the hypotenuse has to be on the side by itself. And then solving here, 8 squared we know is 64, plus 6 squared is 36, and that's equal to X squared. And now remember, when you're doing this, you want to add these together following your order of operations. 64 plus 36, well, that's 100 is equal to x squared. And solving this, if you know the square root property, which you may or may not, if you have x squared equal to just a constant, to solve for x, you can take the square root of each side. Typically, you'll say plus or minus, and I'll explain why in a minute, but since this is the length of the side, we know it's only going to be a positive value for x. So we have x equals the square root of 100, which is 10. And the units on here should be the same units as you had on the other side, so this is 10 feet. So x equals 10 feet. Now, suppose that you didn't know that square root property. So if I pick this up at the step where I had 100 equals x squared, what you may have done is try to solve this by factoring, something that we've talked about earlier in the course. If you did that, you would subtract 100 from each side, and you have 0 is equal to x squared minus 100. And then remember how you solve this by factoring. You should recognize the difference of perfect squares. So you have 0 equals 2 sets of parentheses, x squared is x times x. Negative 100 would be a positive 10 times a negative 10, right? Because it's a perfect square, 10 times 10. And then solving this, you set each of these equal to 0, right? So I would set x plus 10 equal to 0 and x minus 10 equal to 0. You solve each of these individually, subtract 10, you get x equals negative 10, or you add 10 here and add 10 here, you get x equals 10. Now this is old news, you've solved like this before, but the important thing to recognize is that this is an application. This is the side of a triangle, so x equals negative 10 doesn't make sense in this case because distance can't be negative. So, or length of the side can't be negative, so we reject that, and so the answer would just be x equals 10. So, two approaches, I should say 10 feet, right? Two approaches to get you to the same place. I would use the square root property here, especially with the triangle, because it's easier to work with, but you don't have to. Let's take a look at letter B here. Letter B, we, again, are trying to find the unknown side. I'll label it, maybe I'll label it with y this time, just to label it something different. And it's a right triangle, you can tell that because of the 90-degree angle that's indicated there. And you want to find the side y, so you should identify which side is the hypotenuse first. And in this case, the hypotenuse of the side opposite the right angle, be very careful. Here's the right angle, going across from it is the 39 meters. Remember the m here standing for meters, it's not a variable. So we got 39 meters is going to be the hypotenuse. So when I go to set up my Pythagorean theorem, right, and remember you can do that because it's a right triangle, a squared plus b squared, we'll use y as the a, so y squared plus 36 squared equals 39 squared. And then we'll simplify this, so we have y squared plus 36 squared. If we do that on our calculator, I get 1296. And it's equal to 39 squared, which I've got as 1521. Make sure that 39 is the one that's on the side by itself, 39 squared, because that's the hypotenuse. Now you want to solve this for y. To solve this for y, remember we have to isolate the variable here, so I'll subtract 1296 and subtract 1296. So I end up with y squared equals 1521 minus 1296. Gives us 225. And to solve this, I could, try to solve by factoring by getting one side equal to 0, but since I have a perfect square equal to this constant here, if I take the square root of each side, remember I usually would write plus or minus because there's two answers, a positive and a negative, but because I know it's the length of a side, I know it's positive, so I get y equals the square root of 225, which is going to be 15. Right? You can do that on your calculator. And that's 15. What are the units? Well, the units are meters. So the length of that missing side is 15 meters. So Pythagorean Theorem is one place where you'll have the application of quadratic equations. Next, we're going to work through some word problems that also are applications. Some of them are word problems involving just, contrived examples of multiplying things together. Others are going to be based on geometry. So this first one says the product of two numbers, or two positive numbers, is 60. So first off, product is important. Product means what? It means multiply. And we want to determine the two numbers if one number is 7 more than the other. So when you're solving a word problem, the first thing I would do is write let statements defining your variable. And how many things are you looking for? 2. So you should have 2 let statements. And it says, what are the two numbers if one number is 7 more than the other? So I'm going to let x equal, I'll just say, an unknown positive number. And that's important, right? 2 positive numbers, so it has to be a positive number. And then how do I determine the other one? Well, the other one is 7 more than the other. So if this is x, 7 more than that would be x plus 7, right? You see more than, you're adding. So x plus 7 will be the other positive unknown number. So those are 2 let statements, because we're looking for 2 things, and then we'll set up an equation. Now the equation is based off of the words. The equation here says a product means multiply, of 2 positive numbers. Well, these are the 2 numbers, so the product means I want x times x plus 7, and what should it equal? Well, it says is telling you where the equal sign goes. So is 60, so it's equal to 60. And now you want to solve this equation. Now remember how you solve this. So I'm trying to solve this. You can't just set each of these equal to 60, which is the common mistake people make. Remember, that only works if it's equal to 0, because that's a 0 factor property. So here we want to distribute in and then create a quadratic equation we can solve. So x times x will give me x squared. X times a positive 7 gives me plus 7x. That's equal to 60. And to solve a quadratic equation, typically we're going to get one side equal to 0. So I'll subtract 60 from each side. I end up with x squared plus 7x minus 60 equals 0. And then you want to solve this. And the way we solve this is typically by factoring. To factor this, first you should look for a greatest common factor. In this case, I don't see one. All right, and then I should count the number of terms I have. So I have 3 terms, and then I ask myself, do I see a value in front of x squared? In this case, I don't. So that means right away I could try to factor this by making 2 sets of parentheses. Make sure it's still equal to 0. And to factor this, you want things that multiply to whatever c is, the last value. So multiply to negative 60, that constant. And they have to add to whatever the middle coefficient is, whatever that is. In this case, it's a positive 7. So we want numbers that multiply to a negative 60 and add to a positive 7. I know if it's an x squared, the front of these is each going to be x times x. Numbers that multiply to a negative 60 and add to a positive 7. If you know your multiplication facts, it's a little easier than if you don't. But a positive 12 and a negative 5. So plus 12 and minus 5. Now if you're not sure, check it. 12 times negative 5 is negative 60. 12 minus 5 does give you a positive 7. Remember, these numbers are unique. So these are the only numbers you can find. You can change the order of them. It could be a positive 12 here and a negative 5 here, but the sign has to stay the same with the number. And then to solve this, remember now that you have these factored equal to 0, you can set each factor equal to 0 by the zero factor property. So you got x plus 12 equals 0 and x minus 5 equals 0. Solving the first one, we subtract 12 from each side. So I end up with x equals negative 12. And for the second one, I'm going to add 5 and add 5. So I end up with x equals 5. Now, be very careful here. These aren't the two answers, right? We're trying to solve for x. And we solve for x in both of these. But what do we know? I said these numbers have to be positive, right? It's an unknown positive number. So x equals negative 12. We reject that because it's not a positive number. So x equals 5 is the only answer I have that would work. So the first unknown number is 5. How do I find the second one? Well, the second one, use your let statement. It's x plus 7. What was x? X was 5. So this is equal to 5 plus 7, which equals 12. So the numbers that follow these requirements have a product of 60 that are both positive, and one is 7 more than the other, are 5 and 12. You might see this written in set notation. Curly braces indicate a set, so I might see it written as 5 and 12 like that. Either way is okay. If they specifically ask for a set notation in the directions, make sure you answer that way. The only other thing I would point out is that you do have to go through and show the work to solve this. I don't want you just guessing the numbers that multiply to 60 and then figuring it out in your head. That's not using algebra. So we expect you to use algebra. We expect the let statements there. We expect an equation. We expect showing the solving steps. The next one is similar. You may want to pause it and try it on your own, and then come back and watch the solution. But we'll go through it together here. The product, remember product again means multiply. The product of two positive numbers is 80. All right, determine the two numbers if one number is 6 less than twice the other. So first thing is we're looking for two numbers. That means we need two let statements, and make sure you write them. It's worth part of your points on a test. So we're going to let x equal, all right, the first unknown number. We don't know what it is, but one's described in terms of the other. So I'm going to let x equal just an unknown. Again, this is positive in this case. So unknown positive number. And then how do you describe the other one? Well, one number is 6 less than twice the other. So think of the other as being like your x. And you work backwards from that to come up with the other let statement. So 6 less than twice the other. Well, what's twice the other? That'd be 2 times x. And then 6 less than means you're subtracting away. So minus 6. The order matters here. You can't say 6 minus 2x. It's 2x minus 6 because it's 6 less than twice the other. So 2x minus 6 is equal to the, say, other unknown positive number. Okay. Once you have your two let statements, because we're looking for two things, we're ready to set up our equation. The equation in this case, remember it's a product, means multiply. So you want x times 2x minus 6. And that's equal to, the is equal to, remember, is 80. Solving this, we will, again, remember, distribute through. You can't just set it equal to 80, so we'll distribute through here. X times 2x is 2x squared. X times negative 6 is minus 6x, and that's equal to 80. And then you want to get one side equal to 0 when you're solving these quadratics, so we subtract 80 from each side. 80 is not a like term with the other values, so, or the other terms, so we have 2x squared minus 6x minus 80. You want to write this in descending order so it's easier to work with. Don't forget equals 0. You can't just write it without the equals 0 there because then you don't have an equation anymore. And then you want to ask yourself, well, how does this factor if I could factor it? Well, first off, first thing you factor you should be looking for is a GCF. Does this have a greatest common factor? Well, 2x squared, negative 6x, and negative 80? Yeah, it does. GCF here is 2, so you want to factor a 2 out. It'll make the factoring easier. And then you'll be left with x squared minus 3x minus 40 in the parentheses equals 0. Don't try to factor this and then make two sets of parentheses at the same time. You should be taking the GCF out first, then working on this. Otherwise, you'll make some mistakes. So 2 in front, that's the GCF. It'll stay 2 in front. X squared minus 3x minus 40. You should notice you have 3 terms. You don't see a value in front of your x squared. So you can make two sets of parentheses right away there. And you know that reverse FOILing on this, to get to an x squared, you needed x times x. You want numbers that multiply to negative 40. Make sure you're using this equation and not this one. and add to a negative 3. What number is multiplied to negative 40 and add to negative 3? It's important if you know your multiplication facts. You can find this out pretty quickly. We'd have x minus 8 and x plus 5. Negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. So we factored it. And then remember how you solve. You solve by setting each factor that contains a variable equal to 0. 2 doesn't equal 0. You don't have to worry about the 2. You know, sometimes you might see me write this, 2 doesn't equal 0. You can write it for yourself. But the point being is that we're trying to find what would make this whole thing equal 0. The only way you can figure that out is if 2 is 0, which we know it definitely isn't. X minus 8 is 0, x plus 5 is 0. The 2 not equaling 0, you don't have to write it. Just make sure you know 2 is not part of your solution. So we have x minus 8 equals 0. And x plus 5 equals 0. Just a quick thing to point out, if this said 2x, then it could equal 0 because the variable in there could possibly be 0, but 2 itself is a constant, it can't. Okay, solving this first one, we add 8 to each side. I get x equals positive 8. Here I'm going to subtract 5 from each side. I get x equals negative 5. And then you should be aware of, okay, these aren't the two answers. Remember, we wanted positive values, right? That's there. It's also in our let statement. So we are going to reject x equals negative 5. So the first answer we have is x equals 8. That's x. Remember how you find the other value. You substitute into your let statement. So 2x minus 6 means that we're going to use 2 times x, which was 8, minus 6. Well, 2 times 8 is 16 minus 6. That gives me 10. So the values that meet the requirements here are 8 and 10. And if you wanted to write it in set notation, you could. You don't have to. You could just write it next to the let statements like that. That's okay. So keeping in mind that, 8 times 10 would give you 80, and the two numbers, right, 6 less than twice the other, you would have to check that by saying, twice this is 16 minus 6. That does give you 10. So this is similar to the example that we had above, but it is a little different in terms of, when you factor it, you had a GCF in there. So make sure you're still following your factoring rules. The next example here, we say the product of two consecutive positive odd integers is 143. Determine the two integers. So first off, it's a product, means multiply. Two consecutive positive odd integers. Make sure you understand what that means. Positive odd integers. So odd integers are numbers like 1 and 3, right? Consecutive odd integers, I should say, are 1 and 3, 5 and 7, 7 and 9. So they're odd numbers that come right after each other, right? How do you get from 5 to 7? How do you get from 7 to 9? So that's what we're talking about. Odd integers, consecutive means they come one after another. We're looking for two of them. So I'm going to let x, for my first let statement, just equal the first consecutive positive odd integer, right? So I'm defining the variable. Well, how do I talk about the next one? Well, if they're consecutive odd integers, the first one's x, you really have to think about how far apart odd integers are. So if I started with 5, what do I do to it to get to 7? Well, the distance between them is I add 2, right? From 7, how do I get to 9? I add 2. So odd integers are 2 apart. So if the first one's called x, the next one's going to be called x and then plus 2, because it's about the spacing. So this is the second consecutive positive odd integer. So considering it's about the spacing, that's why we use plus 2 here. Sometimes people get thrown off because they think it should be an odd value, an odd number there, but it's not supposed to be an odd number. It's supposed to be about the spacing. From one odd number to get to the next one, you add 2. And the unique thing about this is that even if it was consecutive even integers, you would do the same thing because even numbers are 2 apart, right? How do you get from 6 to 8? You add 2. How do you get from 8 to 10? You would add 2. So you always add 2 when you're talking about consecutive even or consecutive odd. If it just said consecutive integers, those would be 1 apart, like 7 and 8, 8 and 9, 9 and 10. Those are all just add 1. So I've got my two let statements, and now we're ready for an equation. Now the equation's a product, means you're multiplying. This is multiply these together, right? So the first number, x, times the second consecutive positive odd integer times x plus 2 is equal to 143. Now I want to see the work here. You might be able to figure out the numbers without showing it, but I need to see the work to give you full credit. X times x is x squared. X times positive 2 is plus 2x. It's equal to 143. We will subtract 143 from each side to get one side equal to 0. So we end up with x squared plus 2x minus 143 equals 0. And then you want to factor just like you normally would. So the first thing you should ask yourself, is there a greatest common factor? In this case, there is no GCF other than 1. Next thing you want to do is count the number of terms. I have 3 terms, and then ask yourself, do you see a value in front of x squared? The answer in this case, you don't, meaning that there's only a 1 there. So that's letting you know you can factor this right away, or attempt to factor this right away, by just doing a reverse FOIL on it. X squared, you have x times x in your 2 sets of parentheses to get to an x squared. I want numbers that multiply to c, so multiply to negative 143, and I have to add to the middle coefficient, which is 2. So you might need to do some, some guess and check on this to figure out what numbers might be factors of 143. Numbers that multiply to 143, aren't too many of them. There's actually very few. So 143 is 13 times 11. One of them has to be positive, one has to be negative. It's going to be a positive 13 and a negative 11 here. Make sure you know how to figure that out in your calculator for yourself. 13 times negative 11 is negative 143. 13 minus 11 does give me a positive 2. That's how you know which signs you need. Once you have these, we do what we did in the previous problems, which is set each of these equal to 0. So I set x plus 13 equal to 0, x minus 11 equal to 0. For this first one, we'll subtract 13 from each side. Get x equals negative 13. Keeping in mind that consecutive positive odd integers, positive, doesn't meet the requirements, so we can reject that one right away if you notice it. X minus 11 equals 0. We'll add 11 and add 11. So we get x equals 11. That one is positive, so it's good to use. So we have x equals 11. Now it's potential for both of them to reject, and then you wouldn't be able to solve it and there'd be no solution. So make sure that you do check both of them. So x equals 11. We didn't answer the whole question yet, though. We only found the first consecutive positive odd integer. So the first one would be 11. What's the second one? Well, you use your let statement. X plus 2 would be 11 plus 2, which equals 13. Keeping in mind that 11 and 13 are consecutive odd integers. Multiplies together to give you 143. Don't just try to shortcut this by trying to figure out what multiplies 143 and then give me those as the answers. It is true in this case, but it might not always be. The other thing is that I need to see all the work. If you don't show the work, you don't get any credit for that, for just giving me the answer. The work includes defining the variables, showing the equation, solving the equation, and then actually going back and finishing out the problem. Let's take a look at some geometry examples. So we have the area of a rectangular garden. Rectangular is important there. Is 72 square feet. Determine the length and the width of the garden if the length is 2 feet more than 4 times the width. So first question when you're doing a word problem is, how many things are you looking for? In this case, the answer is 2, the length and the width. So we need 2 let statements. I usually start by just saying let x equal one of the unknowns. You want to use it to be the one that you know the least about, remember. So if I say determine the length and width of the garden, if the length is 2 feet more than 4 times the width, I want to let x equal the width, because they told you all about the length in terms of the width, but they didn't tell you anything about the width itself. So x equals the width, and you work backwards from there to figure out the other let statement for the length. Well, the length is 2 feet more than 4 times the width. So working backwards from the width, 4 times the width would be 4x. 2 feet more than that would be plus 2. So that's equal to the length. Once you have that, you have 2 let statements, one for each of your unknowns. You're ready to set up your equation. The equation has to do with what? The area of a rectangular garden. What's the area of a rectangle? The area of a rectangle is equal to length times width, remember. So if this area is 72 square feet, I'm going to put 72 in for A. It's equal to the length, which we defined as 4x plus 2, times the width, which we defined as x. Once you have that, you want to distribute your x through here. We're always going to be in that same type of format unless this was equal to 0. So distribute x in, gives us 72 equals 4x squared plus 2x. And to solve this, we will subtract 72 from each side. So end up with 0 equals 4x squared plus 2x minus 72. And when you're factoring, remember the first thing you want to do to solve this when factoring is look for a greatest common factor. In this case, 4x squared, 2x, and negative 72 all have a 2 in common, so I can write this as 0 equals, factor out the 2, would give us 4x squared, factoring out the 2 gives me 2x squared, 2x factoring out gives me plus just 1x or plus x, and then negative 72 factoring out the 2 gives me negative 36. Once you have this, now you can factor on the inside. You have 3 terms. All right, do you see a value in front of your x squared in here? You do. So you can either choose to use an AC method on this or use trial and error. It's up to you on which method you would prefer. But you know, you should get to the point where you can use trial and error. If you use AC method, that's fine. I'm going to use trial and error on this just to save some time. But if you want to use AC method to factor that, you could. So we end up with 0 equals, this is 2 times. Now, using trial and error, I know I need 2x squared to come from the first part of FOIL, right? When I reverse FOIL this. So 2x squared, I know that 2 times 1 would give me 2. It's the only factors it has. And then x squared would be x times x. So it's 2x times 1x will give me the 2x squared. And now I need numbers that multiply to negative 36. That also, when you do the trial and error, the outer and the inner, when you add those together, you can get a positive 1x out of that. Well, what numbers would do it? You know, it does take some guess and check. It's not necessarily obvious. If you want to think of factors of 36, well, factors of 36, you know, are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 isn't a factor, and then 6 and 6, and then now 7's not a factor, 8's not a factor, and then you're back to 9. So that's the whole list. We know one has to be positive, one has to be negative. And, you know, guessing and checking here, when you do the outer and the inner from FOIL, they should give you a positive 1 in the middle. To save time, we'll kind of think about this. If I did 2x times 4, that would give me an 8x, and then 9 times the x will give me 9x. Those are 1 apart, which is really what you're trying to find. It turns out to be 1 apart. So I could put this as 2x plus 9 and x minus 4. The reason I'm doing that is 2x times a negative 4 gives me a negative 8x, and then 9 times x gives me a positive 9x. Negative 8x plus 9x from the outer and the inner of FOIL does give me a positive x there in the middle. If you did this by AC method, remember you have to rewrite this, use factor by grouping, and then you should get these same 2 factors. Once we factored here, now we want to set each term that has each factor that has a variable equal to 0. 2 doesn't equal 0. You don't have to worry about 2. All right, so we want to really set 2x plus 9 equal to 0 and x minus 4 equal to 0. Solving this, we're going to subtract 9 from each side. You get 2x equals negative 9, and then we'll divide by 2 and divide by 2. I end up with x equals negative 9 halves. Now remember what x is. X is the width. So what can you tell me about it? Can't be negative. So you can reject this because the width can't be negative. And then here at x minus 4 equals 0, solving this, we'll add 4 and add 4. So yeah, x equals 4. 4 is okay. Let's talk about units. It's 4 what? Well, it's 4, the width is measured in, the area is measured in square feet, the width is measured in feet. So the width we know is 4 feet here. Well, what's the length? The length is 4x plus 2. Remember how you find that? You're subbing in the x value into here. So we have this is equal to 4 times the x value of 4 plus 2. 4 times 4 is 16 plus 2. It does give you 18 feet. So the width is 4 feet, the length is 18 feet for this garden here. All right, and those do multiply to give you 72 square feet for the area. So even though I didn't show an AC method on this factoring, I was still able to factor it. You should be able to too, but if you have to use AC method, that's okay. Just make sure you realize it doesn't just jump to this step. You'd have to do some work in between. Let's just take a look at a couple more. We've got the area of a rectangular garden is 180 square feet. Rectangular, right? It's area in a rectangular garden again, that's important. Determine the length and width of the garden if the width is 4/5 its length. So it's a little different in terms of how we said the words, but it's the same type of idea. First question you should ask yourself is how many things am I looking for? And the answer is 2, because we're looking for the length and the width. So I'm going to let x equal, in this case, make sure you pay attention to the problem, right? We're told about the width in terms of the length. So I'm going to let x equal the thing I know the least about, which in this case is the length, which is different than the one above it. So you can't say always equals width or always equals length. You have to talk about it in terms of what they gave you. So the width is 4/5 its length. They didn't tell us anything extra about the length, so x is what you know the least about. Now how do we describe the width in terms of x? Well, the width is 4/5 its length, so the x is the length, so 4/5 times x is equal to the width. Now solving this, right, we want to set up an equation. Our equation has to do with what? It says the area of a rectangle. Well, the area of a rectangle is length times width. What's the area supposed to be? They told us 180 square feet, so we know this is 180, equals the length, which we called x, times the width, which we called just 4/5 x. All right, which is a little different because it doesn't have any addition and subtraction, so it's only one term. So to multiply these, just multiply them together. So x times 4/5 x, the x's get multiplied, right? So x times x is x squared. The 4/5 times the 1 coefficient just stays 4/5. So I end up with this, 180 is equal to 4/5 x squared. And if I'm solving this, typically what I do is I want to clear the fractions and make it easier to work with. So to clear fractions, I multiply both sides by the LCD. The LCD in this case would be 5. It's the only denominator we have, so I'd multiply 5 times 180 is equal to 5 times the 4/5 x squared. The reason we do it is that the 5's cancel. That's why we did that. So 5 times 180, after you multiply those together, gives you 900. You want to do that in your calculator to make sure. It's equal to 4 times x squared, which is 4x squared. And then solving this, you know, you could subtract 900 over and then solve by factoring. Because see, I have an x squared here as a constant, or x squared here term equal to just a constant, I can divide both sides here by 4 to just solve this using the square root property. So I have x squared equals 900 divided by 4. So 900 divided by 4. We get 225. So x squared equals 225. How do I solve for x? Well, I'm going to take the square root of each side. When I take the square root, typically I would write plus or minus, remember, because there's a positive and a negative answer. But because we are talking about the length of a side, we only need the positive. So we get x equals the square root of 225, which we did a little bit earlier, is 15. Make sure you got the units. The units are feet because it's measured in square feet. If you really were solving this, you'd get, you know, by factoring, you'd get x equals positive 15, x equals negative 15, but the negative would get rejected. So x equals 15 feet. That's what? That's the length. Make sure you answer the entire question. The width is 4/5 times 15. So 4/5 times 15 using our let statement. 15 divided by 5 would give you 3. 3 times 4, this ends up equaling 12 feet. So the length is 15 feet. The width is 12 feet. Let's take a look at just this last one here now. So it says the leg of a right triangle is 2 inches more than twice the other leg. The hypotenuse is 13 inches. Find the lengths of all 3 sides of the triangle. So first off, you might want to draw yourself a small triangle here, right triangle. All right, so here's the right angle. And then we'll use let statements as we have before. They told us the hypotenuse already is 13 inches. So when they say find all 3 sides, we know one of them is 13 inches, right? So we have 13 inches for the hypotenuse here. It's always the side opposite the right angle. So once I have that, let's talk about how we describe the other side. It says the leg of a right triangle is 2 inches more than twice the other leg. So I'm going to let x equal, you know, I'm looking for 2 things. I'll let x equal 1 leg of the triangle. Now the other one is 2 inches more than twice the other leg. So this other leg is kind of like our x. 2 inches more than twice that, start here and work backwards. So twice that would be called 2x. 2 inches more than that means plus 2. So that equals, I'll say, another leg. All right, so there's 2 legs of the triangle. All right, these are the lengths of the sides. And what equation am I going to use? They didn't really tell us, right? But we know it's a right triangle, and we're talking about the sides. So what kind of equation relates, the three sides of a right triangle? Well, that equation is the Pythagorean Theorem, right? That's where we started the section. So we know we're using a squared plus b squared equals c squared, keeping in mind that I'm calling, one of these legs x, the other one 2x plus 2. So we're substituting this in. So a squared plus b squared. So a squared, I can call it x squared, taking that side squared, plus b squared. Well, b is the 2x plus 2, so it's 2x plus 2, the quantity squared. And it's equal to c squared. Remember, c is always the hypotenuse, so it's equal to 13 squared. And now to solve this, you got to be careful here. You have to, actually multiply this out, 2x plus 2 times 2x plus 2. You can't just square each piece. That's not how it works. Remember, if there's addition in here, subtraction, you actually have to multiply this times itself, so you're going to have to FOIL that. So this ends up being x squared plus, this is 2x plus 2 times 2x plus 2, which is what this means. Don't just square each piece. That'd be incorrect. Equals 13 squared, which is 169. And we will FOIL this. So we end up with x squared, that's the first x squared, plus FOILing here, 2x times 2x gives me a 4x squared. The outer part of FOIL will give me 2x times 2, which is 4x. The inner part will also give me a positive 4x. This will be plus 8x. And the last terms, 2 times 2, will give me plus 4. So I combine those middle terms of FOIL as I did it. It's equal to 169. And now we'll combine like terms on the left. So we got x squared plus 4x squared will give me 5x squared plus 8x plus 4 equals 169. And now how do I solve a quadratic? Well, I want to get one side equal to 0. So I subtract 169, subtract 169. Make sure you subtract it from the correct term. So I end up with 5x squared plus 8x. A positive 4 minus 169 is minus 165, and that equals 0. Alright, so now once you're here, you want to solve this by factoring. And it's not pretty. It's not the easiest thing to solve by factoring. It may not be obvious what the answers are. But you could, and you should try it, just so you can go through and do it. You could use an AC method on this. I'm going to use a trial and error again, just because when I see that 5 in front, it tells me that, it's a prime number, so I know the factors of the first part of this are going to be 5x and x. You also know that this doesn't have a GCF here, so you should be looking at that first because of the 8. These both have a 5 in common, but the 8 doesn't. So let's try doing this by trial and error with reverse FOIL. 5x squared would be 5x times just a 1x there. And then you want things that multiply to negative 165 that potentially, when you use the outer and the inner of FOIL, could add to an 8x. And the factors of 165 may not be obvious. You might want to, write some of them out. But we know 1 and 165 are factors, but it doesn't look like those would work nicely in here to get us to an 8x, right? Because even if I put the 165 here and the 1 here, it would still be 165, and then minus 5 would only get us to, 160. So we're not even close. 2 is not a factor because, it's an odd number. Is 3 a factor of 165? Well, we can check it. You can do 165 divided by 3. So 55 and 3, so that's 3 and 55. If you were to substitute 3 into here and 55 into here, you're still going to have too big of numbers coming from your outer and your inner. Because, even if you put 5 times 3 here, that'd be 15, but 55x and 15 aren't going to get you to an 8. 4 is not a factor, 165. 5 is a factor. You kind of know this because 55 is a factor. You also know because it ends in a 5. So 165 divided by 5 would be 33. So let's make sure we can take a look at this here. So my outer and my inner, try to add it to an 8. If I put the 33 here and the 5 here, that's not going to be too helpful because this would be 5 times a 33 would give us 165 already, and then we'd have to add in or subtract off the 5x here. It wouldn't come out too great. But if I put the 33 here and the 5 here, 5x times 5 would give me 25x, and this would give me 33x, and 33x and 25x, yeah, they are 8 apart. So now it's just a matter of what's positive, what's negative. Well, you need the 33 to be positive and the 5 to be negative. In other words, 5x times negative 5 gives me negative 25. 33 times x gives me 33x. 33x minus 25x does give me 8. So it gives me 8x. So that's how it would factor. Once you've done this, now you set each of these factors equal to 0. Now if you did AC method on this, you could do it. The numbers would get quite large, but you could do AC method. Remember, AC method does always work if it's factorable, but then you would have to work your way down to this by using factor by grouping. It's not as simple as just making two parentheses. So setting each of these equal to 0, 5x plus 33 equals 0, and x minus 5 equals 0. Here you would take negative 33 from each side, right? Subtract 33 from each side. You get 5x equals negative 33, and then divide by 5. Divide by 5, you get x equals negative 33 fifths. Remember what this is. This is a side of a right triangle. A side of a triangle can't be negative, so you can reject that. Here, we'll add 5 to each side. So you end up with x equals 5. That's nice. It's a positive number, which is good. What's the units on this? Well, the length of the other side was in inches, so this also would be in inches. So 5 inches is the length of one of the legs. Remember, you want to answer the question for all three, so you have 5 inches for one. Your 13 is the hypotenuse in the other leg. Remember, here's x was 5, so you're substituting into there, so this is 2 times 5 plus 2. 2 times 5 is 10 plus 2 will give me 12 inches. Make sure you put the units as inches. And so you found all three sides, right? 5 inches, 12 inches, and we know the hypotenuse is 13 inches. So, hopefully this helped understand some of the word problems and the applications that you might see for quadratic equations. A lot of it is just setting it up. Once you know the setup, usually you can pretty much factor it and solve pretty easily. Be careful on these examples. I did use trial and error. If you didn't use trial and error on these problems, you would have used AC method because you had 3 terms and you saw a value in front of your x squared here and inside these parentheses here. So just be careful there. Make sure you understand how to reverse FOIL that, and if you don't, definitely use an AC method. It'll take a little longer, but it'll get you to the place you need to be. So hopefully this helps.